This is John Black, Super Chemist. This is just a disclaimer to let you know that this video is not intended to be imitated. No parts of it should not be copied or done by you or anybody. It's just for educational and maybe entertainment purposes to watch. That's it. I don't condone anyone repeating anything in the video. Here to try to make some propene. I made propene in another video using aluminum oxide as the dehydrator, and this time I'm going to use sulfuric acid. Here's your alcohol, isopropyl alcohol. Here's your sulfuric acid. It protonates the OH group, makes water. It's a nice leaving group. Since it's a secondary carbon, most likely most of it goes through this, where it becomes a carbocation, and then the hydrogen sulfate ion comes and snags the hydrogen over here, and you get a double bond. I'm sure some of it does go through this reaction though, since it is it's not a tertiary. So you will have some go through this way, where it keeps the water group, and at the same exact time, there's no carbocation. At the same exact time, the water leaves, this hydrogen sulfate plucks off the hydrogen over here. At the same exact time, probably periplanar, and forms your double bond. But either way, it doesn't really matter because they both lead to the same thing. One propene, one water, and you get your sulfuric acid back, because you gave a proton up here, but you get your proton back at the end, so it's just a catalyst. There's the formula down here. You can see I don't put plus sulfuric acid because it's just a catalyst. But this is a dehydration reaction, so I'm going to put a lot of excess sulfuric acid in there, plus I'm barely putting anything in the pot. The pot's going to be like empty. So I am going to put a very good excess in there, so that any water, because you can see every time you make a propene, you make a water. So you need some way to get rid of that water, right? Well, the sulfuric acid will soak that up. There's the molar masses. I took a quarter of every molar mass. So I got 18.6 milliliters of isopropyl alcohol. The sulfuric acid is 98%, so I divided by 0.98, and I got 54.39 milliliters per mole. And then I took that by a quarter, right? Divide that by 4, I get 13.6 milliliters. I'm only going to put 10 in. But that's a lot of excess since it's just a catalyst, you know what I mean? My theoretical yield, which I would probably not get that much, is 42 grams. Divide that by 4 is 10.5 grams of propene. Now, propene's a gas, so anytime you make a gas, you need to figure out exactly how much gas you're making. The ratio of, grams to volume, liters of space that it takes up is unreal. You know what I mean? 10 grams of salt you can put in your hand, you know what I mean? It's nothing. But 10.5 grams of propene, okay? Here's your constant, 22.4 liters per mole. Every gas, if it's, an ideal gas, they're all pretty close, so is that much in volume. So if we did a quarter of the reaction, then we're only going to get a quarter of the mole, right? So a quarter mole, I divided that 22.4 by 4, and I got 5.6 liters. That's how much we're going to make a quarter mole at most. So at most we're going to make 5.6 liters of gas. Keep in mind, if you do this reaction with ethanol to make ethene, you're going to be producing SO2 and CO2. And the SO2 you're really going to want to scrub out of there, you know what I mean? You're going to want to put something in there that has to bubble through, like sodium hydroxide or something, some kind of reducing agent in there, so it, you know, scrubs that out. The best way really is to use the aluminum oxide to do ethene because of that fact. And this reaction, it doesn't happen as much, I'm told. So we'll see. I don't know if you can tell or not, but everything's been put in the freezer. Now I'm adding the rubbing alcohol, but this is anhydrous. There's no water in it. And this sulfuric acid is anhydrous and it's concentrated. I distilled this. You can't get better sulfuric acid than this. Or actually, crap, I used the wrong sulfuric acid. Oh well, too late now. But it has been boiled. Normally I would drip this in, but there's so little, so I don't see the point. So anyways, I'm going to finish putting this in, and I'm going to let it, you know, warm up before I start distilling. Otherwise I'll crack the glass. Alright, I dripped that all in. Can't see them because of glass, but I got boiling stones in there. And just in case things get crazy, don't get good footage or whatever, I wanted to show you my setup. Got a 3-round bottom flask with 2 dead ends. Coming up here, you got I got a condenser, a cold water condenser. Then I just have a Vigorix column, which is basically an air cold condenser. And then I have another small water cooled condenser, but there's no water going through it. So it's just basically an air cooled condenser or Vigorix column, whatever you want to think of it as. Then I got it coming out to this tube here. Tube comes down to this setup right here. Now this is just in there so things don't fall around. Same with this. This gallon is inverted and it's full of water, although you can see it's crushed, so I apparently didn't get all the water out. And then this, it measures stuff real good. I forget what that's called. It's inverted too, and it's full of water. You can see there's just a little bit of air there. See right there. But other than that, it's filled up. I'm thinking that maybe the first stuff that comes over I put into there, because it's going to be a lot of air. You know, the propene gets made and then it just pushes the air out of the way into where I'm collecting. But then after that I can fill up the gallon. So that's, say, 4 liters, 5 liters, and oh crap, we were 5.6 liters. Well, I probably won't make a full, you know, whatever. Alright, so I'm going to start up the heat. I'll get back to you. I got to get this all the way up to 170, 145, 140, 149, somewhere in between there. You're producing ether. You're producing an SN between the two alcohols, which is the same alcohol. If this was ethanol, you'd make diethyl ether. But my whole point is, I don't want to do that. I want the E2 elimination, or the E1 elimination, you know, whichever way you want to think of it, because it's a secondary carbon. So eliminations take a lot of energy. So I want to get this up to 170. Around 150 it starts making it, but you know, you don't want it to go slow, too slow. So I got to get it all the way up to 170 C. Let me get it close and then I'll get another clip in. Now I was only heating it for a minute and it already turned black. So I turned it off, put the camera on. It's already up to like 170 right now. 130. 150. Smells like it's making it, but it ain't burning. Oh, there it is. I don't know if it's making it or not. It's only 150. Doesn't seem to catch on fire. Oh, there we go. See, I'm collecting it. It caught on fire. I don't know if you caught it on film or not, but definitely caught on fire. At least it's coming out slow. I have no crazy stuff happening. Oh, I'm so happy about the speed that it's coming out. This is nice. Thought I was going to be running around with a chicken with his head cut off, trying to collect all this gas. But this might not be a better reaction. They say the aluminum oxide is the best way to dehydrate an alcohol. But boy, this seems like you really have control. I mean, I'm not even doing anything. I just got the heat set at the right temp. It's coming out perfect. It's still going. It almost stopped and I had to suck back. If I wasn't watching, I had to turn the heat up. But look at this, how it's like purple. I don't know if you can see that. I don't know if you can see that on camera or not, but it is like purple. That's unexpected. You can see that. Anyways, I only started out with about 20 milliliters in that flask. I don't want to crack it. You can't see. Look at that. It's just like flying up in there. That must be the ether that you're making. It has to fall back in there. If it gets up to here, production is so low. I just don't want some kind of suck back. Still see it's still producing a little bit, it's just so slow. That is wild how that goes up the condenser like that. That's just all liquid. Probably some kind of ether. I want to stop this before I crack my round bottom flask there. Alright, I got 850 milliliters. I don't know if you can see it there. That was terrible. Should have got 5 minus the 1 in the apparatus, been 4 or 4.6 or something like that. But keep in mind, we only used we only used about 28 milliliters in this flask here. So I mean that's like nothing. I mean, once you get rid of some of that, I mean I can't keep at it 200 C or whatever. You know what I mean? 170 C. That stuff is more black than purple now. It was definitely purple before. Maybe it's carbon from the sulfuric acid breaking down the methanol to carbon itself. You know what I mean? That is a high temperature. I don't know if you can see the stuff on the sides. But that stuff was definitely purple before. I used so little in the beginning, you know what I mean? That's why I got a crappy yield, really. I thought I hit record, but I didn't. I got this round bottom flask. See how I got the 2 valves on it. I connected my pump, vacuum pump to one, closed off the other one. It just has a hose. I pumped the vacuum on this. Then I closed up the one that had the pump on it, and I put this other tube, inside up there, all the way up to the top. And I opened the valve for this one. And the propane got sucked inside here. And as I was pulling, I was standing right here too. I was pulling off the hose, and I pulled this whole thing, and it came apart. The propane all escaped. But it stinks. Always remember, science is great.